Hi everyone. Hi everyone. Today I am going to explain about non-linear wave shaping circuits. So first of all, before going to the non-linear wave shaping circuits, we are going to define the basic definition of the non-linear wave shaping circuit. So here, basic non-linear wave shaping circuit is if we apply an input waveform to one circuit, if the circuit changes the shape of the waveform of the input signal, then we can call that circuit as a wave shaping circuit. If that circuit is consisted with non-linear elements and this non-linear element plays a key role in wave shaping, then we can call that circuit as a non-linear wave shaping circuit. So these non-linear wave shaping circuits are basically classified into two types. One is clipper circuit, next one is clamper circuit. What is the basic definition of clipper circuit and what is the basic definition of clamper circuit? Generally, clipper circuit is used to remove certain portion of the input signal. That means it is used to remove the unnecessary part in the input signal. Whereas clamper circuit is used to shift the input signal from one portion to the another portion. That means from negative axis to the positive axis or positive axis to the negative axis. That means in both the circuits, the shape of the input waveform is altered. But in clipper circuit, certain portion is removed, whereas in clamper circuit, the waveform is preserved, but it can be moved to either upward or downward in clamper circuit. In clipper circuits, basically two types of circuits are there. One is shunt clipper, second one is series clipper. In shunt clipper, there are so many classifications are there: positive clipper, negative clipper, clipping above the reference voltage, clipping below the reference voltage. Whereas in series clipper, also the same classifications are there: positive clipper, negative clipper, clipping above the reference voltage, clipping below the reference voltage. For every classification, we have separate circuit. Now, first coming to the shunt clipper, why we can call this circuit as a shunt clipper? Because here, if you observe this, here the non-linear element is connected in parallel with the input signal. Because of this specific reason, it is named as shunt clipper. That means in shunt clipper, the non-linear element is connected in shunt with the input signal. Hence, it is named as shunt clipper. Now, this is the circuit diagram of positive clipper. So, if you observe this, here Vi represents the input signal, that is clearly represented here. Vi is the input signal. This is the amplitude of the input signal. It varies from 0 to maximum and 0 to minimum. And this is the response produced by the clipper circuit, that is positive clipper circuit, and this is the transfer characteristics of positive clipper. Now here we cannot apply any reference voltage to the circuit. That means we can take 0 voltage as a reference voltage. That means we can take 0 voltage as a reference voltage. That means if the input signal is greater than 0 volts, what is the response of the circuit? If the input signal is less than 0 volts, what is the response of the circuit? Now, coming to the first case, when the input signal is greater than 0 volts, coming to the circuit, when the input signal is greater than 0 volts, that is from 0 to positive maximum and positive maximum to 0. That means, for example, the maximum amplitude of the input signal is taken as 5 volts. For example, the maximum amplitude of the input signal is taken as 5 volts. Then it can be written as the maximum amplitude of the input signal is taken as 5 volts. So it can be written as 5 volts. Now take any voltage between 0 to 5. I will take some 2 volts as a reference voltage. So that 2 volts is applied here. Those 2 volts is applied to the anode of the diode. Those 2 volts is applied to the anode of the diode. It is clearly observed that the cathode of the diode is connected to the ground. It is clearly observed that the cathode of the diode is connected to the ground. That means the voltage at the cathode of the diode is 0 volts. The voltage at the anode of the diode is 2 volts. That means the anode has greater voltage compared with the cathode. Here 2 volts, it is 0 volts. Therefore, the diode is forward bias. The diode is forward bias, it behaves as a short circuit. The diode is forward bias, it behaves as a short circuit. When the diode acts as a short circuit, the voltage, output voltage across the short circuit is equal to 0. The output voltage across the short circuit is equal to 0. The output voltage across the short circuit is equal to 0. This voltage is 0. That is clearly represented here. That means for the positive cycle of the input signal, the diode is on, it behaves as a short circuit and its output voltage is 0. Now coming to the negative portion of the input signal, in the negative portion of the input signal varies from 0 to minus 5 volts. Now take any voltage that I will take minus 3 volts as an input signal. Now that minus 3 volts is applied to the circuit, that is here, minus 3 volts applied as an input signal, that is appeared at anode of the diode, that is minus 3 volts. And here the cathode is directly connected to the ground, that means 0 volts. Now if you observe this, the voltage at the anode is minus 3 volts and voltage at the cathode is 0 volts. That means the voltage at the cathode has greater voltage compared with the anode because it has 0 volts cathode. But anode has minus 3 volts, it is less compared with the 0 volts. That means the diode acts as an open circuit. When the diode acts as an open circuit, what happens? The entire input signal is connected to this one. Plus is connected to this, minus is connected to this. Therefore, the output voltage V0 is equal to the input voltage. So, whatever the input voltage is there, the same voltage is appeared at this point. But for the positive peak of the input signal, the diode is on, it behaves as a short circuit, therefore V0 is equal to 0. So if you observe the output response, the positive portion of the input signal is clipped off by the circuit. Hence, it is called as positive clipper circuit. That means the circuit removes the positive portion of the input signal, hence it is named as positive clipper circuit. Now coming to the transfer characteristics. Here, if you see this, when the input signal goes on increasing or goes on decreasing, the output signal is 0. Whatever may be the input signal, 0 or 1, 2, 3, 4, 5 or 5, 4, 3, 2, 1, the output signal is 0. But the output is 0. That means here when the input signal is increasing from 0 to 5 volts on x-axis, it goes on increasing from 0 to 5 volts. But there is no output voltage. Here the output voltage is 0. Hence, we can get the transfer characteristics like this. That means when Vi increases from 0 to 5 but the output is 0, hence it appears like this. In this period, the diode is on. That is clearly represented here. Next, coming to the negative cycle, during the negative cycle, when the input signal increases or decreases, the output response also increases or decreases. That means there is a linear relationship between input as well as output. These two are directly proportional to each other. So if you observe this, when the input signal increases, output also increases. This is input, this is output. Both are increasing in a proportionate manner. Therefore, we get linearly increasing signal. That means in this case, the diode is off. In this case, the diode is off. This is Vi, this is V0. This is Vi, this is V0. So this represents the transfer characteristics of positive clipper. Now coming to the negative clipper, simply the diode is reversed. Nothing is changed. Simply the diode is reversed. Now we can apply an input signal Vi to this circuit. Now we can apply an input signal Vi to this circuit. Now here also there is no reference voltage at the diode. There is no reference voltage. There is no reference voltage means the voltage at the anode of the diode is 0 volts. The voltage at the anode of the diode is 0 volts. And here there is no reference means the 0 volts is taken as the reference voltage. 0 volts is taken as the reference voltage. That 0 volts is applied here. Now coming to the first case, that is when the input signal is greater than 0 volts, that is taken as the first case. When the input signal is less than 0 volts, that is taken as the second case. Now coming to the first case, that is when EI is greater than 0. Coming to the first case, when Vi is greater than 0. When Vi is greater than 0 means the amplitude varies from 0 to 5 volts. Take any voltage at between these two, 0 to 5 volts, 1, 2, 3, 4, 5, like that. I will take some 4 volts as an example. For the 4 volts, that 4 volts is applied here. That 4 is applied to the cathode of the diode. That positive 4 volts is applied to the cathode of the diode. Therefore, because of this 4 volts at the cathode, that means the anode has 0 volts, but the cathode has 4 volts. That means the voltage at the anode is less than the voltage at the cathode. Therefore, the diode D is off. It behaves as an open circuit. When the diode acts as an open circuit, there is no flow of current through it. That means the entire current passes through the V0. That means this plus is directly connected to this one, this minus is directly connected to this one. Therefore, the output voltage V0 is equal to Vi. The output voltage V0 is equal to Vi. That means during the positive cycle of the input signal, V0 is equal to Vi. That means when the input signal increases, output also increases. When the input signal decreases, output also decreases. The input is similar to the output signal. Now coming to the negative cycle of the input signal, that is for Vi less than 0. For Vi less than 0, that is from 0 to minus 5 volts and minus 5 volts to 0 volts. Take any voltage, I will take minus 2 volts as a input. That minus 2 volts is applied to the anode of the diode. So because of this minus 2 volts, the voltage at the anode is 0 volts because it is directly connected to the ground. That means the cathode has minus 2 volts, anode has 0 volts. That means the voltage at the anode is greater than the voltage at the cathode. So because of this, the diode is on, it behaves as a short circuit. The diode is on, it behaves as a short circuit. When the diode acts as a short circuit, the resistance of the diode is 0. When the diode acts as a short circuit, the resistance of the diode is 0 because short circuit have 0 resistance. So because of the 0 resistance, the entire current passes through this diode. There is no flow of carriers through it because it has 0 resistance. That's why the entire current passes through it and reaches to the ground. Therefore, the voltage across this short circuit, because the diode is acts as a short circuit and this cathode is connected to this one, this anode is connected to this one, but the diode acts as a short circuit. Therefore, voltage across the short circuit is 0 volts. That is clearly represented here. That means during the negative cycle of the input signal, because of the diode is on, it behaves as a short circuit, the output is equal to 0. Whatever may be the input signal from 0 to minus 5 or minus 5 to 0, the output is 0 volts. So if you observe this output signal, it is clearly represents that during the negative cycle of the input signal, the output is 0. That means the circuit removes negative portion of the input signal. Hence, it is named as negative clipper. The circuit removes the negative portion of the input signal. Hence, it is named as negative clipper. And if you observe this, during the positive portion, the input is equal to the output. That means the output and input are similar in positive section, but the output is 0 for negative section. Hence, it is named as negative clipper. Now, coming to the transfer characteristics, if you see that when the input signal increases from 0 to 5, the output also increases from 0 to 5. If the input signal decreases from 5 to 0, the output also decreases from 5 to 0. That means there is a linear relationship between output and input in positive cycle of the input signal. When the input increases, output also increases. Therefore, this linear relationship is indicated here, that is Vi versus V naught in positive section. In this section, the diode is off, that is clearly mentioned here. Now coming to the negative axis, when the input signal decreases from 0 to -5, the output is 0. Similarly, when the input signal decreases from -5 to 0, increases from -5 to 0, again the output is 0. Even though the input signal increases or decreases, there is no output voltage, 0. Because of this, the transfer characteristics is plotted on x-axis only. And in this case, the diode is on, that is clearly mentioned here. This is the VI characteristics or transfer characteristics of negative clipper circuit. This is about the working of positive clipper as well as negative clipper. For the positive clipper, the entire positive portion of the input signal is removed, and for the negative clipper, the entire negative portion of the input signal is removed. So because of these two specific properties, those are named as positive clipper as well as negative clipper circuits. So in the next class, we are going to discuss about the clipping above the reference voltage and clipping below the reference voltage. Next classes, these two circuits we are going to discuss. Thank you so much for your patience listening.